Hello again. Today we're going to apply the Pythagorean theorem on the coordinate plane. Okay, first couple examples here. It says use the Pythagorean theorem to find the lengths of the following line segments. So the length here, you could also call this the distance between the 2 points. So you could say length of the segment or the distance between the 2 points. But the way we are going to do that is actually by drawing in a right triangle where this length is the hypotenuse. And we're going to draw in a horizontal segment and a vertical segment to go along with that hypotenuse. So what that creates here is a right angle. And then this length, as I said, is the hypotenuse. Okay, so let's label the triangle lengths we know. The horizontal here is 1, 2, 3, has a length of 3, and the vertical also has a length of 3. Okay, and then here's the hypotenuse, and in the Pythagorean theorem, we're going to call that the c value. So a squared plus b squared equals c squared. So just like we did in the last lesson. Okay, so here we get 9 plus 9 equals c squared. That is 18 equals c squared. Again, you're going to square root both sides. I'm just going to say that officially it is plus or minus, but from here on out, I'm just going to use the positive version. So c is going to be the positive version of the square root of 18. Now that one, a 9 divides into 18. So I'm going to change this to square root of 9 times the square root of 2. So my final answer is 3 root 2. Okay, so this length of the segment or the distance between the points, final answer is 3 root 2. Second example. So again, we're finding this distance or the length of the segment. I'm going to draw a horizontal and a vertical. And then again, that makes a right angle here. So in order to find the length here, I'm going to figure out the coordinates, well, the length, I should say, the distance between, or the horizontal distance here and the vertical distance here. So this is a length of 2, and this is 1, 2, 3, 4, 5, 6 squares. So that is a length of 6. So pause and calculate distance or the length. Okay, so welcome back. You're going to set up the Pythagorean theorem again. Okay, that's going to be 4 plus that's 36. You can, of course, use a calculator. So you get 40 equals c squared. So now you're going to square root both sides. And it should be officially plus or minus, but for geometry links, it's just the positive version. Okay, now a perfect square. Again, if you need to, you can always just write your perfect squares off to the side here. So let me just do that really quickly. And these do go on, right? There's more of them, but these are the usual ones. Okay, so the most obvious one is 4, and I don't think any of these others divide into 40. So in this case, we're going to use the 4. So square root of 4 times the square root of 10 is 40, and then square root of 4 is 2. So here I get 2 root 10. Okay, good. So that's an application for the Pythagorean theorem if you're finding the length of a segment or the distance between 2 points. Now, distance formula is actually very much related to the Pythagorean theorem. In fact, if you look at this formula, you see here's something squared plus something squared, and then we're going to take the square root. Basically exactly what we just did in both of these examples. It's just written out in a different format. So the distance formula is, if you have your 2 points, you are going to take your x values and subtract those, and then take your y values and subtract those. Now, when you subtract in math, that is just finding the change in the x values, and all that is the horizontal distance. Again, when you subtract the y values, you're finding the change in y's, and that is just going to be the vertical distance. Okay, so let's try one here using the formula instead of straight Pythagorean theorem. So this is x1, y1, this is x2, y2. So the distance between the points, I like to set up my skeleton, is what I like to call it. The skeleton of the formula looks like what was written here in black. And then I'm going to plug in my values. So x2, so 3 minus 1, and then y2 is negative 2 minus, and then be careful, you're subtracting a negative 5. So you need to say minus a negative 5. Okay, so next step in that, we're going to simplify inside the parentheses. So 3 minus 1 is 2 squared. Negative 2 minus a negative 5. Remember, minus a negative is plus. So negative 2 plus 5 is 3 squared. Okay, next, so we're going to square these. And I get square root of 4 plus 9. And then put those together and you get square root of 13. So my final answer, I'm going to leave these as these weird radical answers, square root of 13. Okay, I'll get you started on this second one and then I would like you to try it. So this is x1, y1, this is x2, y2, and then I'll start you off with the skeleton of the formula, which is parentheses squared plus parentheses squared. Okay, so pause, plug in, and find a final answer. Okay, welcome back. Here you have negative 5 minus 2, and then y2 is 8 minus the 1, which is y1. Okay, the next step in the process is simplifying in the parentheses. Negative 5 minus 2 is negative 7 squared. And then 8 minus 1 is 7 squared. Okay, now we're going to simplify the squareds. So be careful here. Negative 7 squared is actually negative 7 times a negative 7. That is positive 49. So just be really careful about that. But you get a positive 49 plus, again, a positive 49, which is the square root of 98. Now, I'll give you a little hint here, but since I have 49s in both places, this is 2 times 49. And that's actually helpful because 49 is a perfect square. So I'm going to change this to 49 times 2, so square root of 49 times square root of 2, and then my final answer here is 7. Because the square root of 49 is 7, I get 7 root 2. Okay, next part. So now we're going to do an example where we compare the two methods. Okay, so first thing we're going to do is find the distance between the points. We're going to plot the points. So negative 1, 5 is A, and then 3, 1 is B. So we're going to find this distance. Try and draw a straight line. Find that distance, and we're going to do that with the Pythagorean theorem and then with the distance formula. Okay, Pythagorean theorem. So like I did above, I'm going to highlight the horizontal distance and then the vertical distance. And what that does again creates a right angle. So I want you to try, without me writing any lengths here, try to figure out the length of segment AB. So pause and do that. Okay, welcome back. So again, this is going to be the hypotenuse. The horizontal length here is 1, 2, 3, 4. And the vertical length is 1, 2, 3, 4 as well. That 4 didn't come out so good. So we have 4 squared plus 4 squared is equal to c squared. 16 plus 16 equals c squared. 32 equals c squared. Square root that. Again, we're really only interested in the positive version for geometry. And then we're trying to find a perfect square that goes into 32. Like I said with the 49s, you'll notice 16 plus 16 is the same as 16 times 2. So I'm just going to rewrite this as 16 times 2. So root 16 times root 2. Root 16 is 4. And then you get the root 2. So there is the length of that segment using the Pythagorean theorem in the picture. Distance formula. So the c value for the Pythagorean theorem is the same as the d in the distance formula. So let's make the skeleton. That's squared. Okay, and then we're going to plug in x1, y1, x2, y2. Okay, so 3 minus the negative 1, and then 1 minus the 5. Okay, so pause and simplify that. Okay, we'll come back here. So simplify in the parentheses first. Remember, this is minus a negative is a plus. And then 1 minus 5 is negative 4. And that's going to be squared as well. Okay, so here I get 16. And again, negative 4 times a negative 4 is still a positive 16, which is square root of 32. And then you'll notice it looks exactly the same as what we did here. So that is going to be, again, 4 root 2. Okay, compare the two methods. So it should be fairly obvious here. 4 root 2 is the same for both methods. So what that means here, the Pythagorean theorem method and the distance formula method are actually equivalent. You will get the same answer, doesn't matter which method that you use. Okay, good job. We'll see you next time.